everyone, welcome to our group assignment video about techniques of differentiation under MAT183 Calculus 1. I'm Muhammad FARIS bin Muhammad FADILLAH together with AMIRUL FARHAN, Muhammad IDLAN HAKIMI and Muhammad HAKIMI. We are from RCDCS 1102E group. Before we start, why do we need differentiation in our life? Well, it's not just theory, it's practical and used everywhere. It's used in physics, economics, biology, and in engineering.
Today we're going to discuss about differentiation and derivative. So what is derivative and differentiation? For the definition of differentiation is a core idea in calculus. In calculus, it measures how a function changes as its input changes. The result is called the derivative, which tells us the rate of change or the slope of the function's tangent line at any point. So we're going to see basic rules. First one is constant function. The derivative is 0. Linear functions, the derivative is the coefficient of x, and the power rule for x power of n, the derivative is n as power of n minus 1. Some and different rules. Derivatives can be added or subtracted term by term. Product rule for u times v, the derivative is uv square uv prime plus vu prime. For quotient rule, u over v is vu prime minus uv prime over v square. Chain rule for composite functions, multiply the derivative of the inner and outer functions. Trigonometric function, for the example, the derivative of sin x will be cos x, and the exponential and logarithmic functions, e power of x stays the same when differentiate. The derivative of in x is 1 over x. And lastly, implicit differentiation used when y is defined implicitly in terms of x. As the conclusion, differentiation is a powerful tool in calculus with wide application in physics, engineering, and economics. It helps understand rates of change, optimize system, and model real-world phenomena. Mastering these techniques is essential for advanced mathematics and scientific problem solving. That's all for now.
Assalamualaikum warahmatullahi wabarakatuh. I am ABDUL JALIL and I'm going to show you how to solve question 2. First, we're going to answer question 2a, which is I have to find dy dx for the following function, which is 3x power of 2 secant that multiply with x plus 2. So first, for this question, we're going to use using product rule, which is our u is 3x power of 2 and our v is secant that divided x plus 2. So our u prime is 6x and our v prime is secant x plus 2 and tangent x plus 2. So for the question, we just have to put the u multiplied with v prime, which is 3x power of 2 that multiplied with secant x plus 2 and tangent x plus 2. Then we're going to plus secant x plus 2 that multiply with our u prime, which is 6x. So our final answer is going to be 3x power of 2 secant x plus 2 tangent x plus 2 plus 6x secant x plus 2. So the conclusion is we're going to use the product rule because it's a multiplication of two parts, which is 3x power of 2 and secant that multiply with x plus 2. So we move for the question 2b, which is find the dy dx for the y equal to 4x plus 2 that divided by cos x. For this question, we're going to use quotient rule, which is v that multiply with u prime minus u that multiply with v prime and divided with v2. So we notify that our u is 4x plus 2 and u prime is going to be 4 and our v is cos x and our v prime is going to be minus sin x, negative sin x. So here how to solve it, we're going to using the quotient rule, which is v multiplied with u prime, which is cos x, so that multiplied with 4 and then minus with our VEU, which is 4x plus 2 and multiply with our v prime, which is negative sin x, that n divided with cos x 2. So our final answer is going to be 4 cos x plus 4x plus 2 and multiply with sin x and divide with cos x, cos power of 2x. we're going to use quotient rule because the function is a division that including with two functions.
Hi, my name is Muhammad Faris and I will show how to solve the problem for question 3. So in this question, we need to find dy over dx for the equation that gave. First, we differentiate a function that includes y ln 3x. This is a product of two functions, so we apply the product rule formula that I show on right screen and we get dy over dx equal to ln 3x plus with y over x. Next, there is exponential term and we apply the exponential rule, which is straightforward, and we get negative 2e power of 2x plus 1. Then we have something like negative tan for y, which is a bit more tricky. For this, we use the chain rule because it's a composition of functions. When we differentiate negative tan for y, we get negative 4z power of 2 multiply 4y and multiply with dy over dx. After that, we move to the algebraic part. We combine and clear all the terms with dy over dx on one side of the equation. Then we factor it out and solve for dy over dx to get our final answer. So for the final answer, we get dy over dx equal to 2e power of 2x plus 1 minus y over x divided with ln 3x minus 4z power of 2 multiplied with 4y. So to sum up, implicit differentiation is super helpful when y and x are integral in an equation. It allows us to deal with more complex functions and apply calculus in more advanced scenarios, like curve in engineering or biological system.
Hi everyone, my name is Mohamad HAKIMI. I will show you how to solve question 4. The question asks you to use line approximation to estimate the value of the fourth root of 80.99 minus 2 divided by the square root of 80.99. Firstly, we start by defining the function that matches the expression. Then we find its derivative by differentiate the function. So this is the derivative of f that we get. For the second step, we need to let s equals to 80.99, which is the given value, while x naught is equal to 81, which is the chosen value. 81 is picked because it is the closest integer number to x. Delta x is equal to x minus x naught, therefore delta x is equal to negative 0.01. Next, we apply the linear approximation formula to estimate the value of this question. Function f of x naught we plus with f prime of x naught that have been multiplied by the delta x. So f of 81 we plus with f prime of 81 that multiplied by negative 0.01. Now that we have set up our formula, let's plug in the actual values. So for the parenthesis in the first bracket, 81 power of 1 over 4 is 3, while the 81 power of 1 over 2 is 9, so it becomes 2 over 9. For the parenthesis in the second bracket, 81 power of 3 over 4 times 4 is equal to 108, so it becomes 1 over 108. While the second parenthesis, which is 81 power of 3 over 2 is 729, so it becomes 1 over 729. So putting it all together, we get an estimate value of 2.778, accurate to 3 decimal place. To wrap up, linear approximation is a fast and smart way to estimate difficult expression using known value and derivative while avoiding complex root calculation.
Thank you for watching. We hope you understand how to use the technique of differentiation to solve Calculus 1 question in the future. See you next time. Bye!